سلام طبعا خوشويست chapter 10 legal tambardaan dabin other organic compound. It's similar to organic compound, but even we have C and H in chapter 9, we have C, H and O and N in halogens, which is known as function group. Function group is an atom or group of atoms that is responsible for a given property in this compound. A function group undergoes the same type of chemical reaction in the group. Or we can say the function group is the location of chemical reactivity of the compound. Of course, the compound which has the same group, they can classify this to the same type of compound. The first group is alcohol. Alcohol is an organic compound which has OH group, known as hydroxyl group. OH negative is hydroxide. Be careful. Hydroxyl group is bond OH. It's hydroxyl group. The general formula of alcohols are OH. The R is carbon, alkyl group. 1 carbon, 2 carbons, 3 carbons, and so on. It's CnH2n plus 2O. Like alkane, it has more atom, more oxygen than alkane. The function group is OH. In all compounds, remove the L, the remaining group will be function group. Alcohol nomenclature. In alcohols, locate the longest continuous chain of carbon to be the parent hydrocarbon and contains hydroxyl group. It's similar to alkene. Number it from the side that has the OH group to take the lowest number possible and locate the location of OH in which number and name the parent hydrocarbon as follows. According to the number of carbon, write alkane plus ol for 1 OH plus diol for 2 OHs plus triol for 3 OHs. For example, CH3OH, it has only 1 carbon. So it will be methane. Alkane has 1 carbon, it's alkane, yani methane plus ol, because it has 1 OH. So it will be methanol. It has a common name, methyl alcohol, or we can say wood alcohol. For 2 carbons, it will be ethane or ethyl alcohol. For 3 carbons, you have to number it from the side that has the OH group. In the first one, we have OH on the number 1 on the right side. So you have to start the numbering from right side. 1, 2, and 3. Locate the OH group. It has number 1. So you have to write 1. 1 is the location of OH. Slash. Name of parent is prop. To be alkane, you have to add propane and add OL. To be alcohol, 1 propanol. And the second one, we have OH in the middle, so you can number it from any side. 1, 2, 3. The location of OH is 2, so you have to write 2 prop, make it alkane, yani propane, and add O, yani 2 propanol. 1 and 2 propanol are structure isomer to each other, so it will be structure isomer. Here we have 2 OH, so we have to number it 1 and 2, because both carbon has OH. Right, the location of OH is 1 and 2, and name of parent is ethane plus O, so it will be ethane diol. Ethane diol. For this one is 1, 2, 3. 1, 2, and 3. Propane triol. Both ethanediol and propanediol has common name. Ethylene glycol and glycerol. It's common name for 1, 2 ethanediol and 1, 2, 3 propane triol. Without OH, this one is cyclopropane without OH, right? This one is cyclohexane. We add all, and it's cyclopropane, add all, cyclopropanol. Right, the coordinate structure for these compounds, 2,3-pentanediol. 2,3-pentanediol. We have diol, يعني 2 OHs on the 3 and 2. So we have 5 carbons. Number it as you like. 1, 2, 3, 4, and 5. On the 2 and 3, we have 2 hydroxyl group. On the 2 and 3, we have 2 hydroxyl group. Here we have triol, يعني 3 hydroxyl groups, 3 OH groups. On the 3, 1, and 5. 1, 2, 3, 4, 5, and 6. Number it as you like. And on the 1, 3, and 5, you have to add 3 OH groups. The other one is homework. 3-ethyl, 2,3-dimethyl, 1-hexanol. We have mistake name for alcohols. 3,4-pentanediol. Write the correct name for this compound. It's incorrect. Be careful. 3,4-pentanediol. Write the structure of the incorrect name and name it at the first. We have 5 carbons, pent. On the 3 and 4, we have 2 OH groups. Number it as you like. 1, 2, 3, 4, and 5. On the 3 and 4. On the 3 and 4, we have OH. It's incorrect. Remove the numbers and number it at the first. You have to start numbering from the side that has the OH group. So you have to number it from left side. It's 1, 2, 3, 4, and 5. So the correct name is 2,3-pentanediol, because you have 2 OHs. Pentanediol. The other is homework. Properties and uses of alcohols. It's similar to alkene in boiling point. When the carbon atom increases, the boiling point is also increased. Just in this point, it's similar to alkane, be careful. But the other one is not. For example, we have a stronger intermolecular force between alcohols, which is known as a hydrogen bond between 2 alcohols, ROH and ROH. We have hydrogen bonding. It's strong intermolecular force. It's not one, it's intermolecular force between hydrogen and oxygen in 2 different molecules. In hydrogen in a molecule and oxygen in another one. We have hydrogen bonding. This hydrogen bonding is so strong, so it needs more energy, extra energy to get the boiling point or to boil it. So which one has the higher boiling point, alkane or alcohol? Of course, alcohols has the higher boiling point, because between alkanes we have no hydrogen bonding, just we have a weak London force between them. So the boiling point of alcohols is much larger than and much more than alkanes. In alcohol, when the number of OH increases, the boiling point is also increased, because the number of hydrogen bonding will increase. يعني when we have 3 OHs, the boiling point will be greater than 2 OHs, and it's greater than 1 OH. يعني sorry, it's not negative, it's just OH. And 3 OH triol is greater than diol and greater than all in alcohols. Because alcohol can form hydrogen bond with water, so it can dissolve in water. It's unlike alkane. Alkane cannot dissolve in water because it's non-polar. But alcohol, ROH, the OH side is polar. The OH side is polar, but the R is non-polar. but it's polar. So it can dissolve in water. But the solubility tends to decrease with increasing the number of carbon. Yani, a lower carbon atom in alcohol will be soluble in water. When the carbon atom increases, the solubility tends to decrease because the non-polar part will be dominant in the molecule. But the bigger alcohol cannot dissolve in water. So we have different solubility of alcohols. A lower R, lower carbon, and lower mass can dissolve in water. When the carbon atom increase, the solubility will decrease. It's not insoluble completely, but decrease. But when the carbon atom is much large, like octanol, like nonanol, it will be insoluble in water because the non-polar part or region will be dominant. The other property is 1,2,3 propane triol, which is known like glycerol, used in what? In cold cream or lipsticks in body lotion. Because it can absorb or attract the water molecule in air to the skin and keep the skin moist. So all glycerol's compounds are what as moistures, because keep skin moist. Another property or another uses for alcohols used to alternative fuels, and it's octane enhancer. So octane enhancer is the second way to increase the octane number for gasolines by adding of ethanol. The first way is adding of isooctane. The second is adding of ethanol. Not all alcohols, just ethanol. Ethanol combined with gasoline by 1:9 ratio, which is known by gasohol. It can increase or octane enhancer for gasolines. It has two advantages and two disadvantages. The advantage of gasohol is it's burned more cleanly than benzene or gasoline and help save dollars petrol. يعني اقتصادي. Okay, and we have disadvantage of gasohol. Why? Because it can produce only 60% than benzene. يعني the energy of gasohol is lower than benzene, or we can say gasoline. And ethanol can absorb water to the gasoline, and it's disadvantage. And all simple alcohols are poisonous, like methanol and ethanol. When ethanol drinks, by enzyme alcohol dehydrogenase, it converts more, rapidly converts. When ethanol drinks, by enzyme alcohol dehydrogenase, convert to what? To acetaldehyde and acetic acid rapidly change to acetaldehyde and acetic acid. But when the methanol drinks, convert to formaldehyde and formic acid by the same enzyme more slowly. So when the methanol drinks, damage optic nerve and coma, and then some dying about it, death. No, because it's more toxic than the ethanol. Why? Because the conversion is so slowly. A molecular compound which dissolves in water and it doesn't ionize. يعني it's not acid. Okay, it's not base, it's not salts. Which one can dissolve in water? At first, A can dissolve in water because it's alcohol. Benzene cannot dissolve in water. Salt can dissolve in water. Weak acid can dissolve in water. But he said it doesn't ionize. Both C and D. C dissociate in water, so it's incorrect. D dissolve but ionize in water, so it's also incorrect. But alcohol dissolve in water, but it cannot ionize in water, so it will be A. Other organic compound is alkyl halide, or we can say haloalkane, because it contains halogen. It contains what? Halogen. Alkyl halide. Halide means halogen. It's haloalkane. Haloalkane, it contains halogen atom. Alkyl halides are organic compounds in which one or more halogen atoms replaced by H in alkane. The general formula is Rx. The functional group X. Remove L, R in each compound. The remaining part is what? X. So it's functional group. X refers to what? F, Cl, or Br, or I. Nomenclature of alkyl halide. Find the longest continuous chain to be parent hydrocarbon, and but contain the halogen, of course. And number it from the side that the halogen take the lowest number possible, and from the side that has the X, the halogen group. And write the name of halogens in alphabetical order. First, you have to name the Br, and then Br as bromo, not bromine, bromo, chlorine for chloro, and fluoro with iodo. And name the parent hydrocarbon as alkane without any change. The first one has one carbon, so it will be number of carbon is 1, so it's me. 1 me. But the halogen is Cl, so write the halogen name first, chloro, and name of parent is methane. So it's chloromethane. The common name is methyl chloride. You can replace chloride by fluoride, by bromide, by iodide. So it will be methyl bromide, methyl chloride, and methyl iodide. The second one is ethane. Ethane. So the parent is ethane. Before name of parent is what? Name of halogen. Yani it's bromo. So it's bromoethane. The common name is ethyl bromide. Or we can replace the Br by another X, F, Cl, or I. Here we have 3 carbons, so you have to number it. From which side? From the side that the X is closest to the ends. It's the same, so you can number it from any side in it. 1, 2, 3. On the number 2 we have I, so you have to write 2 iodo, and the name of the parent is propane. 2 iodo propane. Here we have F from right side, so you have to number it from right side. It's 1, 2, 3, and 4. Write the location of X. It's 1, 2, 3. Name of X is fluoro, so you have to write tri fluoro, and parent is write butane. 1, 2, 3 trifluoro butane. Here you have Br. From the left side you have to write, so you have to write the numbers from the left side. 1, 2, 3, 4, and 5. Write the location of X of Br is 1, the first one, and the second one is also 1, the third one is also 1, so you have to write 1, 1, 1, and 2, so you have to write tetra, because we have 4 halogens, 4 Brs. Tetra, parent is pent, so it's pentane. 1, 2, 1, 1, sorry, 1, 1, 2 tetra, sorry, I forgot the name of halogen. It's bromo. It's bromo. 1, 1, 1, 2 tetra bromo pentane. Here we have 2 different halogens. Number 8 from the side that has more halogens to be lowest number possible. Yani from right side. 1, 2, 3, 4, and 5. So it's 1 bromo, 1 bromo. Bromo comes before chloro, so you have to write B bromo. and then chloro, it's 1, 3, and 5. Tri chloro, and 5 carbons is pentane. If we have two different halogens on the same carbon, like Cl and Br, for example, Cl here, and here. You can start numbering from each side, right or left is the same. But if you have two different halogens here, you have to write from the side that comes first in alphabetical order, because we have two halogens on the number 1 here and 2 here, so you have to write from the one that comes first in alphabetical order. Yani 1, 2, 3, 4, 5. It's 1 bromo, 1, 3, 5, 5 tetrachloropentane. Write the structure formula for 1,1 trichloro 3,3 difluorobutane. You have at first write the parent hydrocarbon, so you have to write 4 carbons. 1, 2, 3, and 4. Number it from the side that you need. It's 1, 2, 3, 4. 1, 1, 1. And 3 times on the 1 we have 3 halogen atom. It's chloro, yani Cl, Cl, Cl. And on the 3 and 3 we have difluoro, 3, 3 difluoro, yani F and F. Other one, it's 1 bromo, 1, 1, 3, 3, 3 penta-iodo-propane. Penta-iodo-propane, yani we have 3 carbons. It's 1, 2, 3. On the 1 we have Br. On the 1, 1, yani 2 times 1. On the 3, 3, 3. 3 times 3 we have penta-iodo. Penta-iodo yani I. It's I, and I. The other one is homework. Which of the following is named incorrectly according to IUPAC system? 2,2-dichloro, 1,1 difluoropropane. We have 3 carbons. We have 3 carbons. Prop, 3 carbons. On the 1,1 we have difluoro, 3 carbons. 1, 1 difluoro. And 2,2-dichloro. 2,2-dichloro. It's correct. Why? Because the halogens are closest to the right side. So you have to number it from right side. 1, 2, and 3. And at first you have to name the chloro because it comes first in alphabetical order. So it's 2,2-dichloro, 1,1 difluoropropane. So it's correct. B. 3-butanol. 3-butanol. But yani 4. 1, 2, 3, 4. On the 3 we have OH. Of course it's incorrect. Why? Because you have to number it from the side that has the OH. Or we can say the OH is closest to the left side. So you have to write 1, 2 here. So it will be 2-butanol. Yani it's incorrect. B. C. 1-methyl 2-ethyl cyclopropane. Of course the ethyl must be written before methyl. So it's incorrect. Because of alphabetical order. The ethyl must be here, and the first one you have to number it 1 and 2. So it's incorrect. Yani B is true answer. B and C are incorrect. The property of alkyl halide, we have CFCS. CFCS is shortcut for chlorofluorocarbons compound. Yani we have many shortcuts. Be careful. The first one is CFC. Is C, yani chloro, F, fluoro, carbons compound, C. Are alkyl halide that contain both chlorine and fluorine gas. Both freon 11 and 12, or we can say CFC 11 and 12, or trifluoro trichlorofluoromethane, and difluoromethane. Common name is for 11 and 12, and the shortcut is CFC 11 and 12. Both CFC 11 and 12 are odorless, non-toxic, non-flammable, and very stable, and they can easily change from one state to another. This property is a good property, and this property makes it useful for what? For production of plastic foam and liquid refrigerators. Plastic foam, okay, and liquid refrigerators. يعني split تبريد سعري. Okay, so لازقهم وأنا contains CFCS and 12, CFC 11 and 12. The disadvantage of CFCS, they contribute to the destruction of ozone upper atmosphere, and they can damage ozone layer upper atmosphere when they replace two atmosphere by these reactions. It's disadvantage. We know the ozone is the upper atmosphere help us to what, or prevent to downward to ultraviolet radiation that cause to what, to skin cancer. And another alkyl halide is tetrafluoroethene, which is known by Teflon, its common name C2F4. Sorry, we can use it in what, heat resistant machine part, cause the bond between carbon and fluorine in Teflon is unreactive. So why Teflon used as a heat resistant machine part? Cause it's what, unreactive. It contains the unreactive, or the bond between C and F in Teflon is unreactive, and also we can use it as a what? Utensils with non-stick surface, protection of what? Utensils for and often with non-stick surface. Why? Because it has a low coefficient of friction. It has a low coefficient of friction, so it will be non-stick. Teflon or Tefal, it's the same. The other organic compound is ethers. Ethers are organic compounds in which two are combined to the same oxygen atom at the same time. Yani R, O, and R. Two are combined to the same oxygen atom directly. Okay, so it will be ethers. And remove the R's, the remaining atom will be functional group. It has the same function. It has the same number of carbon and hydrogen with oxygen to alcohol. It's CnH2n plus 2O. The general molecular formula of alcohol and ethers are the same, but the general formula is ROR. Remove the R's, remain also. O is functional group. The nomenclature of ethers is so easy. How? Right? Okay. So the nomenclature of ethers is so easy. Write the name of R's as alkyl group, like methyl, ethyl, and then what ether. If the ether has the same alkyl group, say di-alkyl group and war ether. But if it has two different alkyl groups, write the one that comes first in alphabetical order and then what ether. For example, in the first one we have two same alkyl groups, CH3 and CH3. So you have to write di-methyl, not methyl, huh? It's di-methyl, and what ether instead of O. Ether, di-methyl ether. Here we have different alkyl groups, methyl and ethyl, E and M. methyl side with M, ethyl with E. So which one comes first in alphabetical order? You have to write the name of ethyl. So it's ethyl, methyl, and ethyl. Here we have two same groups, ethyl and ethyl. Right, diethyl, and ether. This is known by ethyl ether. The common name for diethyl ether is ethyl ether. Here we have two different alkyl groups. On the right side you have butyl, left side ethyl. So B comes first in alphabetical order. So you have to write butyl, ethyl, and 1 ether. The other one has cyclo. It's not popular, it's dicyclo. Cyclo what? We have 3 carbons, so it's dicyclopropyl ether. And here we have dicyclo. It has 6 carbons, so it's dicyclohexyl ether. Dicyclohexyl ether. And this one has normal alkyl group and cyclo. So you have to write the name of ethyl first and cyclopropyl, because E comes first in alphabetical order. So it's ethyl, cyclo, propyl, and ether, because E before P, not C, not C, P. The other one is homework and property of ethers. The solubility of ether is like to or similar to alcohols. Why? Because it can form hydrogen bonding with water. So between ethers and water, we have hydrogen bonding. Why? Because ethers has oxygen atom and water has H atom combined with O, or more electronegativity element. So between O in ether and H in water, we can form hydrogen bonding. So it can dissolve in water. And solubility of alcohol and ethers are similar. Why? Because both can form hydrogen bonding with water. But between ethers, we have no hydrogen bonding. Between ethers, we have no hydrogen bonding, unlike alcohols. In alcohols, we have hydrogen bonding between alcohol and alcohol, but between ethers, we have no hydrogen bonding because we have no hydrogen atom combined with high electronegativity element, means oxygen. Yani the H doesn't combine with oxygen in ether, so it can form hydrogen bonding. So the boiling point of alcohols will be much higher than the boiling point of ether. Yani boiling point of ROH is much higher than the boiling point of ethers, ROR. Why? Because between alcohols we have hydrogen bonding, thus between ethers we have no hydrogen bonding. Unlike alkane, ethers are not very reactive. Yani they are unreactive. So alkanes and ethers are similar in reactivity. Both are unreactive. So we can use as a solvent because it's unreactive. Yani if it said why ether is used as a solvent, you have to say what? Because they are unreactive or not very reactive. The other property or uses of ethers is MTBE, it's shortcut. Be careful. We have CFCS, CFC11, 12, and MTBE as a shortcut. M refers to what? Methyl. M is methyl. T, tertiary. B, butyl. E, ether. MTBE. Use a what? Is an octane enhancer of gasoline. So it's a third way to increase the octane number or octane ratio. The first one is what? Isooctane. Second one is ethanol, and the third one is MTBE. We can use it instead of tetraethyl lead. When it's burned in exhaust, it produces PbO2. It's toxic. So we used MTBE instead of tetraethyl lead. When compared the dimethyl ether and ethanol, which of the following is correct? Ethanol is CH3, CH2, and OH. But dimethyl ether is CH3OCH3. Both has the same general molecular formula because both has C2H6O, and here we have C2H6O. Which one is correct? Both have the same function group. It's incorrect. The function group of alcohol is OH, but for ethers is O, so it's not correct. B, both have the same boiling point. It's not correct. Boiling point of alcohol is greater than the boiling point of ethers, because between alcohols we have hydrogen bonding. C, both dissolve in water. It's true, because both can form hydrogen bond with water, not to each other. D, all of them is incorrect, so C is correct answer. The other one, which of the following organic compounds is used as an octane enhancer? The first one is ethanol, it's true. Second one, glycerol, it's moisture, not true. MTBE is true, so it's both A and C. If B, right, isooctane, it's also true. So it will be all of them. Isooctane, ethanol, and MTBE used as a what? As octane enhancer. Question 5 in section review. Arrange the following compounds by decreasing boiling point. And which one has a higher, and then to lower, and to the least. Which one has the high boiling point? The one that has a OH group. Who has an OH group? Ethanol and 1,2-ethanediol. Both has OH groups. But because ethanediol has two OH groups, so it has a higher boiling point than the other one. 1, 2, 3, 4, and 5. The first one is 3, so it has the highest boiling point because it has 2 OH groups. The second one is ethanol, it's number 2, and it's greater than who? In ethyl, methyl ether, or butane or propane, you have to look at the mass. Which one has a higher mass? It has the highest boiling point. Ethyl, methyl ether, or butane or propane. Which has a higher mass? The mass of butane and ethyl, methyl ether are nearly similar. Thus, we have O here. The mass of oxygen is slightly greater than the mass of carbon. O is 16, C is 12. So the boiling point of ether will be greater, yani it's 1. And then, who has a higher boiling point? Butane or propane? Butane has a higher mass, it will be greater. So butane is 4, and then 5. Section 2, we have more classes of organic compound. The first one is aldehyde and ketones. In aldehyde and ketones, we have a new function group. It's carbonyl group. It's carbonyl group. Carbonyl group means C double bond O, and C combining with O directly without H, like alcohol. It's ROH. We have O in alcohols combined with carbon and H. Look, ROH. And O combined with H and carbon. But here, directly, O combined with carbon atom by double bond. So both has the same function group. Sorry, same carbonyl group. But the difference between them is the location of carbonyl group. Yani aldehyde and ketone contains C double bond O. But the function group is different, huh? Agadarba. So aldehydes are organic compounds in which the carbonyl group attached to the carbon atom at the end of carbon atom chain, and it's first. But ketone, it's the organic compounds in which the carbonyl group attached to the carbon atom within the chain. But in aldehyde, at the end of the chain, so it's C double bond OH. Always the carbon atom in aldehyde, which has a carbon group, is the number one and first one always. So remove the R, the remaining part will be function group. It's C double bond OH. But in ketones, we have carbon group attached to the carbon atom within the chain. Yani, remove the R, so the CO, just CO will be function group for ketones. And both contain CO, yani carbonyl group, but the function group for aldehyde is C double bond OH, ketone C double bond O. The nomenclature of aldehyde. Look, it's aldehyde, yani you have to add aldehyde to the name of alkane. Always the carbon that has the carbonyl group in C double bond O is number 1, and number it from the side that has the C double bond O. And then write the number of carbon in the parent as alkane plus Al. Here we have only one carbon, so it's methane plus Al, so it's methanol. Look, methane plus Al, it's methanol. For 2 carbons, it will be ethane. Add Al, because aldehyde. How do you know it's aldehyde? The carbon group attached to the first one, yani not within the chain. The third one is 3 carbons, so it's propane. Add Al, it will be propanol. Always in the first one and second one we have common name. The first one, methanol, has a common name of what? Formaldehyde. And ethanol is acid aldehyde. If we have a group, always we have to number it from the side that has the carbon group, yani C double bond O. And it's 1, 2, 3, 4, and 5. We have 2 groups on the 2 and 4. So it's 2, 4 dimethyl. And the aldehyde is pent. It's pentane. Add Al to be aldehyde. So it's 2, 4 dimethyl pentanol. This one has one group. Start it from the side that has CO. So it's always number 1, 2, 3. Write the number and the name of group. It's 2-methyl. And the name of parent is propane, and add Al to be aldehyde. 2-methyl propanol. This one is homework. Draw the common structure for 2,3,4 trimethyl hexanol. Hexanol yani 6 carbons. 6 carbons. 1, 2, 3, 4, 5, and 6. Always the first one is C double bond O. So it's 1, 2, 3, 4, 5, and 6. Because we have Al, so we have aldehyde. And on the 2, 3, 4, on the 2, on the 3, on the 4, we have tri-methyls. Yani C, C, and C. Ketone nomenclature. This time we have to locate the longest continuous chain that has the CO group, or we can say carbonyl group, and number it from the side that this carbonyl group is the closest to the ends to take the lowest number possible, and then locate the number of CO, and write the location of CO in the ketone, and then write alkane plus on, yani ONE. In ketone, you have to write ONE and add ONE to the alkane, but in aldehyde, write Al. Yani alkane plus Al. But here, you have to write the location of CO and then name of the parent according to the number of carbon by alkanes, and then write ONE. The smallest ketone has 3 carbons. Yani in ketones, the number of carbon atom is not less than 3 carbon. Be careful. Yani here it's 1, 2, 3. It's 2. We have 3 carbons. Yani prop. Make it alkane, so it's propane, and add ONE. So it's 2-propanol, which is known by acetone. It's common name. Here we have CO on the left side. Number it from left side, so it will be 2 butane and ONE, so it's 2 butanol. 2 butanol. Instead of CROH or CROR, we can write it in this form, RCOH. It's not alcohol, be careful. Alcohol is ROH, alcohol. But here we have aldehyde, RCOH, and C double bond OH. And in ketone, we can write it in this form, RCO and R. It's not ether, huh? Be careful. ROR is ethers, but here we have RC double bond with O and R, so it's ketone. It's ketone. Okay. Here, the CO is in the middle, so you can number it from each side. Right or left is the same. 1, 2, 3, 4, and 5. Location of CO is 3. 5 carbons and pentane, and add ONE. So it's 3 pentanol. But here we have branch on the right side and the CO in the middle. So you have to number it from the side that has the branch. But if the CO is located here, you have to write from the left side, not on the side that has a branch. 1, 2, 3, 4, and 5. We have to write the name of number and name of the groups or the branch. It's 2-methyl. 2-methyl. And the location of CO is 3, so we write 3. Name of parent is pent. It's pentane, and add ONE to the pentanol. Pentanol. According to the IUPAC system, the compound CH3, CH2, CH2, COH, be careful, it's C double bond OH, is called what? It's not alcohol. It's not alcohol, so it's not butanol. It's not butanol. Prop is 3, we have 4 carbons, it's incorrect. Butanol is ketone, butanol is aldehyde, because the C double bond O is at the first, so it will be butanol. It is located within the chain, yani if it's CH3, CH2, CO, and CH2, sorry, CH3, it will be butanol, but you have to write the name, so the location of CO, it's 2 butanol. But here we have CO on the first, yani it's butanol يعني D. In ketones we have cyclic form. We have cyclic form. Write the structure formula for cyclohexanone. Cyclohexanone يعني we have hexagon because it's hexagon and on يعني C double bond O. Write the C double bond O in any carbon. It's true. In any one, it's true. The property of aldehyde and ketones. The simplest aldehyde is methanol, which is known by formaldehyde, known as a formaldehyde, used in what? Used in biology lab as a preservative. And the simplest aldehyde is formaldehyde with phenol using in one production of plastic bakelite. And the smallest ketone is 2-propanol, which is known by acetone. It's nail polish remover. Nail polish remover. And aldehyde and ketones are responsible for odors or flavor or some what we have here, vanillin. We need it. You have to memorize vanillin, just vanillin, not about the others. Vanillin has 3 function groups. It's vanilla. Vanillin is vanilla. It has the 3 function group OH, O, and C double bond O. Function group of vanillin is O, OH, and C double bond O. Cinnamaldehyde is cinnamon. The name of the flavor and the odors of cinnamon is cinnamaldehyde, and raspberry and benzaldehyde all has the nice flavor and odors. The other organic compound is carboxylic acid. Carboxylic acid is an organic compound which has a carboxylic group. Carboxylic group يعني C double bond O and OH. It's carboxyl group, carboxyl function group. The general formula of carboxylic acid is R, C double bond O and OH. It's organic acid. It's organic acid. The function group is remove R, remain what? C double bond O and OH. So the function group is C double bond OH. And the general molecular formula is CnH2n and O2. In aldehyde and ketone, we have aldehyde and ketone, we have CnH2n and O. Aldehyde and ketone. Aldehyde and on ketone, we have CnH2n O. But here we have CnH2n O2. And it has 1 oxygen more than the aldehyde and ketone. The nomenclature is so easy for carboxylic acids. Always the COOH is the number 1 and name the parent hydrocarbon as alkane plus OIC acid. And the first carboxylic acid, we have 1 carbon, C double bond OH, it's H. So the smallest carboxylic acid has 1 carbon. According to the alkane, we have methane. Add OIC, so it will be methanoic acid. Methanoic acid is formic acid. It's C double bond OH. In general formula, we can write carboxylic acid as follows: RCOOH and RC double bond OH. They are the same. Here we have CH3COOH. It's ethanoic acid. It's acetic acid. Acetic acid. Here we have 3 carbons, so it will be propane. add OIC acid. So it will be propanoic acid. The other one has 4 carbons, so it will be butane plus OIC acid, butanoic acid. Here just we have a common name, it's oxalic acid. It's oxalic acid, H2C2 and O4 is oxalic acid. The static name is ethene acid. Ethene acid is not in the rules. Properties and uses. The property of carboxylic acid is same to the property of acetic acid in chapter 2. O can accept proton, donate proton to water, yani increase the H3O ion in aqueous solution, and they all is much weaker than the inorganic acids. And citric acid has 3 carboxylic acid, you have to memorize it. Citric acid, lemons, has 3 carboxylic acid, and some carboxylic acid used as food additive like ethanol, like citric acid. It's vinegar. And benzene propanoic with sulfuric can use as a what? As preservatives. مواد حافظة preservatives. The most widely used carboxylic acid is methanol and ethanol because it's so inexpensive. Specifically ethanol is in what? In production of polyvinyl acetate. It's PVA, polyvinyl acetate, used in what? In latex paint. The other organic compound is ester. Ester organic compound with carboxylic acid group, in which the hydrogen atom in carboxylic acid has been replaced by what? By R, alkyl group, yani R. Yani it will be RCOOR instead of RCOOH. In carboxylic group we have what? We have RCOOH in carboxylic group. But here we have R, yani H replaced by R in carboxylic acid to be esters. So it will be RCOOR. The general molecular formula is CnH2nO2, yani it's same to carboxylic acid. The nomenclature of esters is different from carboxylic group. Always in carboxylic group, write the name on the right side, yani R as alkyl group, methyl, ethyl, propyl, and so on. And the left side, name it as alkane plus OATE. Here we have COO esters. The right side is methyl. And the left side is what? 1 carbon, so it's methane. And right is methyl, alkyl, left is alkane, so it's methane plus OATE. It's methanoate. The common name is methyl is the same, and formate. Yani common name of methanoate is formate. We can't change the methyl, but the methanoic, no, it's always formate. The second one has 1 carbon on the left side, so it will be methyl. And the left side has 2 carbons, so it will be ethane plus what? OATE. Methyl ethanoate. The common name of ethanoate is acetate. So the common name will be methyl acetate. We can't change the methyl to another one, but acetate is constant. It's also the same for methanoate. Methanoate is formate. Here on the right side we have 3 carbons, so it will be propyl. 3 carbons. On the left side we have 2 carbons, so it's ethanoate. Ethane plus OATE, ethanoate. Because The right side, sorry, the left side has 2 carbons, it will be acetate. But the propyl is the same. Propyl acetate is the common name of propyl ethanoate. Also, we have 2 carbons here. The oxygen is okay. 2 carbons on the right and 2 on the left. Yani ethyl. Yani ethanoate. Ethane O-A-T-E. O-A-T-E, ethanoate. Because the right side, sorry, because the left side has 2 carbons, it's ethanoate, we can write the common name. It's ethyl acetate. Ethyl acetate for ethyl ethanoate. In these examples, we have a common name for butyl methanoate, just propanoate, and it doesn't have a common name because it has 3 carbons. 3 carbons here. And also for propanoate. But for methanoate, we have a common name. It's butyl methanoate changed to what? To formate. So it's butyl formate. Yeah. The molecular formula of ethyl ethanoate is what? Ethyl ethanoate is ester. Ethyl ethanoate is ester. How many carbon atoms we have in this compound? 2 for ethyl and 2 for ethanoate. So commonly we have 4 carbons. So it will be C4H. The general molecular formula for ester is what? CnH2n and O2. So it's Cn and 4 and H will be 8 and O2. 1 O is incorrect, 1 O is incorrect, 2 O and 2 O. Who has 8 hydrogen? B. So B is correct answer. And A is incorrect. The property and uses of ethers. All esters are responsible for some flavor and odor for plants. And they are natural. They are natural. And they are used in a what? Synthetic or production of what? Juices. For example, banana. Isoamyl acetate is an ester which has the same flavor and same odor of what? Of banana. So we can use this as a what? As juice of banana. So it's flavor. The last organic compound in section 3 in chapter 10 is amines. Amines are organic compound in which contain nitrogen atom, and it's different from the others. Why? Because it has nitrogen atom. All are has a halogen or CO and H, but here we have nitrogen atom. Organic compounds can be derivative of what? Derivative of ammonia. Ammonia is NH3. So ammonia is not amine. Ammonia is a weak base. When you change or convert or replace the 1 or 2 or all hydrogens by alkyl group or R, it will be amine. So it's ammonia, it's amine. Right? Ammonia, amine. The functional group is what? Is N. Remove the R's, it will be N. So N is functional group. The general molecular formula is CnH2n plus 3N. Plus 3, be careful, N. Nomenclature of amines is same to ethers. Name all alkyl groups as methyl ethyl and word amine. If they are the same, write tri and name of alkyl group and then amine. If they differ to each other as alphabetical order, name the alkyl groups and word ether. And the first one we have 1 carbon, just 1 carbon. So it's methyl. 1 carbon is methyl. And N is amine. So it's methyl, amine. Here we have 2 carbons. So it will be, not 2 carbons, sorry, 2 alkyl groups. Each has 1 carbon. So it will be dimethyl. dimethyl, and or amine, dimethylamine. Here we have 2 carbon on the same side of N, so it will be ethyl. And this one is different from this one. We have 2 carbon on the different side of N, on the same side of N, so it will be ethylamine. Ethylamine. Here we have 3 same groups on the same carbon, on the same nitrogen atom, so it will be tri. Tri, 1, 2, 3, yani tri. It's methyl, then it's trimethylamine. Trimethylamine. Here we have 3 different groups. So the first we have to name the one that comes first in alphabetical order. It's E, M, and P. Who comes first in alphabetical order? Of course, E. So you have to write ethyl. Ethyl. And M is second one, so it will be methyl, and then propyl, ethyl, methyl, propyl, and amine. Here we have 1, 2, and 4. 4 is B, 2 is E, ethyl, and 1 is M. The first one is B, so it's butyl, and then ethyl with methyl. And what amine? So it's butyl, ethyl, methyl, amine. Here we have 2 same groups, and the other one is different. It's M and P. Who comes first in alphabetical order? M. So it's methyl, both are the same, so it will be dipropyl, and what amine? We have question here. The molecular formula for each of the following organic compound is C3H9N. Who has 3 carbons? Here we have trimethyl, yani 3 carbons. So A is true because it's amine. A is true because it's amine. But B is ethyl methyl. Ethyl has 2 carbons. Here we have 3. We have 2 carbons and methyl. Methyl is 1. And 2, it will be 3. Also B is true. And propylamine. Propyl has 3 carbons. And C is also correct. So it will be all of them. It will be all of them. We have 3 groups of amines according to replacing of hydrogen in ammonia. We have primary, secondary, and tertiary. In primary, only 1 hydrogen replaced by alkyl group. In secondary, 2 hydrogens will be replaced, but in tertiary, all hydrogens and 3 hydrogen will be replaced by alkyl group. For example, here we have 1 R replaced, one H replaced by 1 R. So it will be primary. And here we have 2 carbons on the 2 different sides of N, and 2 R's replaced by, 2 H replaced by R, so it will be secondary. Here we have 2 carbons on the same side, and 1 H replaced, so it will be secondary. But here we have 6 carbons, it's tertiary. We have 3 carbons, tertiary. So we have to focus on the hydrogens which are replaced by R, not number of carbons. Here we have 1 carbon, and 1. 3 carbons, it will be tertiary. But if these 3 carbons attach to the same N in one side, it will be primary. It will be primary. Be careful. Yani the primary, secondary, and tertiary doesn't depend on the number of carbon. It depends on the replacing of hydrogen by alkyl group, or we can say R. The property of amine is same to property of ammonia in chapter 2. It's weak base. So also all amines has the same property of ammonia. They act as a weak base in aqueous solution according to all definitions. For example, in aqueous solution it can increase the OH ion, so its base according to Arrhenius. and it can accept proton in a solution to be positive according to Bronsted and Lowry. And on the nitrogen you have pair of electrons, you can donate it, so it will be base according to Lowry's definition. And amines are common in nature. They are often formed during the broken down the protein in animal. Protein formed from what? Amino acids. When the protein decomposed in animal cell produces what? Amino acid, and the amino acid decomposed to what? Acid, or we can see carboxylic acid, and amine. And we have some classes of organic compound contains nitrogen atoms known as alkaloid. Alkaloid and bases like caffeine, like nicotine, like codeine, any drugs, all drugs is amines: nicotine, morphine, codeine, caffeine, and we can use as pain reliever, for example, morphine. And we have a toxic molecule in poison dart frog, which has two poison called what? Batrachotoxin and batrachotoxin A. Batrachotoxin and batrachotoxin A. This table is the summary of all organic compounds in section 1 and 2. The first one is alcohol. Name is alcohol. The functional group is OH, but the general formula is ROH. The general molecular formula is CnH2n plus 2O. It's alkanol. Second one is RX. It's haloalkane. The third one is same to alcohol in general molecular formula, but general formula no. It's ROR. It's alkyl ether. Aldehyde has a functional group of C double bond OH, but ketone CO. Both contain the carbon group, but the functional group is different. And nitrogen in amine is a functional group. Both carboxylic acid and ester has the same, has the COO group, but different functional group. And but it have the same, and they have the same general molecular formula. It's CnH2nO2, but different molecular formula. General molecular formula is the same, but general formula is different.